So welcome, this is a video based upon empirical formula and molecular formula. So what is empirical formula? So empirical formula is a formula showing the simplest ratio between the elements. So let me write it out over here. Empirical formula. It is a formula showing, what does it shows? It shows simplest ratio. Simplest ratio. Ratio between what? Between elements. Simplest ratio between elements. For example, CH3 and CH4. This is the simplest ratio is 1:3 and 1:4. What about molecular formula? Molecular formula is the formula showing actual ratios. Formula showing actual ratios. For example, between the elements. Same actual ratios between elements. So for example, C2H6, the actual ratio is C2:6, whereas the simplest ratio is going to be nothing but how much? 1:3. Similarly, C3H12, the actual ratio is 3:12, but the simplest ratio is going to be nothing but what? 1:4. That is the way how we are going to define both empirical formula and molecular formula. So what am I going to do it at? For example, I do it at an example over here. A compound will be having 80% of carbon and 20% of hydrogen. Now write the empirical formula. So first, before going to the worksheet, I do some examples, then it will be easy. So what am I going to do? Make two columns, carbon, hydrogen. Carbon is 80, hydrogen is nothing but what? 20. So once I could able to get that one, now I am going to divide with atomic mass. Divide with atomic mass. So what is that atomic mass? For carbon it is 12, for hydrogen it is 1. So am I going to get it out? How much do I get it out? 6.67 for carbon and 20 for hydrogen. Then what am I going to do? Divide by smallest. Divide by smallest. So what is the smallest over here? 6.67. So divide by 6.67. So what do I get it out? 1 over here and 3 over here. So the ratio is going to be 1:3. So which is CH3. In this way, I'm going to do that. Now, I'm going to do the basic worksheet, which has something around 10 questions. So let us try to solve that worksheet now. So, first question. An oxide of chromium is found to have following percentages of chromium and oxygen. Determine its empirical formula. So, chromium is 68.4 and whereas oxygen is 31.6. Now what am I going to do with it? I'm going to divide by their atomic mass, which is 52, and for oxygen it is going to be 16. So I get over here 1.315, and over here I'll be getting it at 1.975. The smallest is being 1.315, so divide with 1.315. So divide with 1.315, so I'll be getting it at 1 and 1.5. So what will be the formula now? It will be chromium is 1 and oxygen is 1.5, but these numbers can be never be in decimals. So multiply by 2, chromium is 2, oxygen is 3. This is going to be the empirical formula. Question number 2, the percentage composition of a compound was found to be 63.5% of silver. Silver is Ag, which is 63.5%. Next is nitrogen, which is 8.2%. Next is oxygen, which is 28.3%. So what am I going to do it? Divide by the atomic masses. So for that, for silver, when I see from the periodic table, it is 107/7, and for nitrogen it is 14, and for oxygen it is 16. When I divide, I'll be getting it out 0.589, 0.585, and 1.769. Now I further divide it with the smallest one. The smallest one is 0.585, and everything with the smallest ratio 0.585. Then I get it out approximately 1 over here, 1 over here, 3 over here. So what is my empirical formula? AgNO3. Question number 3. A 170 grams of sample of an unidentified compound contains 29.84 grams of sodium. Then chromium is 67.49 grams, and oxygen is 72.67 grams. What am I going to do that? Divide by their atomic masses. For sodium, I am going to divide with, but first of all we have to convert into percentages. This is totally 170. So divide each one with 170 because we need to convert into percentages first. 170. So it becomes 17.55, 39.7 and 42.7. After that, divide by their atomic masses. So which is nothing but what, 23, and this is 52 for chromium, and for oxygen it is 16. So when I do that, I should be getting 0.76, 0.76 and 2.7. So which is the smallest one? The smallest one is 0.76. So divide with 0.76. So it becomes 1, 1 and 3.5. We know that it should not be in decimals. Basically it is NaCrO 3.5, which is wrong. It should not be in decimals. So therefore multiply by 2, Na2 Cr2 Cr2O7. This is going to be the answer. Question number 4. A 60-gram sample of tetraethyl lead, a gasoline additive, is found to contain 38.43 grams of lead, 17.83 grams of carbon, 3.74 grams of hydrogen. So I'm taking it out lead, which is 38.43. Then carbon 17.83. Then hydrogen 3.74. But it is out of 60 grams. So convert into percentages. So divide by 60. When I divide by 60, it becomes 64.05, 29.72 and 6.23. Further, I will be dividing with the atomic masses of lead is 207.2 and it is 12.01 and 1.01. So what am I going to get it out? I am going to get 0.3, 2.47, 6.17. Now, which is the smallest one? The smallest one is being nothing but what? 0.3. So 0.3, 0.3 and 0.3. So what am I going to get? 1, 8.2 and 21. So it is Pb, C8 and H21. This is going to be the answer. Question number 5. A compound containing 5.9265% of hydrogen, 94.0735% of oxygen. Already the percentages are given and the molar mass is also given. Find the empirical formula and the molecular formula. So for hydrogen, how much is that? 5.9265 grams or percentage. Then for oxygen, it is 94.0735, 075 or 0735. Now what am I going to do with that? I am going to divide by their, what is this, weights. So atomic mass, which is 1 and which is 16. So I'll be getting it out same, 5.92, and when I do this one it will be getting it out 5.88. So further, which is the smallest one? 5.88. I divide with 5.88. So both are equals to 1. This is 1 and this is 1. So therefore empirical formula is HO. Now what is empirical formula mass? Which is 1 plus 16, which is 17. Now molar mass. How much is the molar mass is given? 34. So N equals to molar mass divided by empirical formula mass, which is 34 upon 17, which is 2. So what will be the molecular formula? Molecular formula will be HO times 2, which is H2O2. That's going to be the answer. Question number 6. For question number 6, the empirical formula of trichloroisocyanuric acid, an active ingredient in many household bleaches, is this one. The molar mass is 232.41. What is the molecular formula for this one? So we have to find it out N. So what is N? Is molar mass of molecular formula divided by molar mass of empirical formula. Molar mass of molecular formula is 232.41, whereas empirical formula, you calculate it out. What does it becomes? Oxygen is 16, carbon is 12, nitrogen is 17, 14, and chlorine is 35.5 or 35.4. So when I divide that one, 232.41 divided by 77.5, which becomes 3. So what will be the formula? O3, C3, N3, Cl3. Question number 7. Determine the molecular formula of a compound with an empirical formula NH2 and formula mass 32.06. So we need to calculate N, which is molar mass of molecular formula divided by molar mass of empirical formula, which is 32.06 divided by NH2. Nitrogen is 14 and hydrogen is 1 times 2, 2. So total it is 16. So divided by 16, so which becomes 2. So NH2 times 2. So that becomes N2H4. Question number 8. The empirical formula of a hydrocarbon compound that contains only carbon and hydrogen is found to have CH. Laboratory procedures have found that the molar mass is 78. What is the molecular formula? So again find N, which is molar mass of molecular formula divided by molar mass of empirical formula, which is 78, and carbon is 612 and hydrogen is 1, so 13. 78 divided by 13, which is 6. So multiply by 6, it becomes C6H6. Question number 9. The molar mass of nicotine is 162.1 grams per mole. It contains 74% of carbon. Carbon is 74%. And hydrogen is 8.7%. Nitrogen is 17.3%. Now what am I going to do? Divide by 12, 1 and 14. So it becomes 5.1, 7.25 and 1.2. What am I doing further? Divide by the smallest one. Smallest one is 1.2, 1.2 and 1.2. So what does that becomes now? This becomes this ratio over here is an error over here. So what am I going to do? 74 divided by 12 was not 5.1, it was 6.17. 8.7 divided by 1 is 8.7. 17.3 divided by 14 is 1.2. Now divide by 1.2 is the smallest one. So what does that becomes now? This becomes 5.1, 7.25 and 1.2. So what is that now? Empirical formula C5H7N1. This is the empirical formula. Now we need to calculate N. How do I calculate N? Molecular mass of molecular formula, which is 162.1 divided by 12 times 5 and 7 times 1 and 14. Divide it out, you'll be getting 81. So 81, so N value is 2. So molecular formula will be times 2, C10, H14 and N2. Last question. Phenyl magnesium bromide is used as a Grignard reagent in organic synthesis. Determine the empirical and molecular formula of molar mass is given if it contains carbon, which is 39.7458, and hydrogen is 2.77956, and magnesium is 13.4050, and bromine is 44.0697. So I divide by their atomic masses. For carbon 12, for hydrogen 1, for magnesium 24.3, for bromine 80. I get 3.38, 2.78, 0.55, 0.55. Which is the smallest one? 0.55. So divide with 0.55, the smallest one, which gives me 6, 5, 1, 1. So what is the empirical formula? Empirical formula is C6H5Mg Br. Now I need to calculate N. How do I calculate N? N equals to molar mass of molecular formula divided by molar mass of empirical formula, which is 181.313 divided by 181.3, which is 1. So my molecular formula will be the same, C6H5Mg Br. This is going to be the answer. So that completes the worksheet about empirical formula and molecular formula. See you in the next video. Bye.